In this movie, I want to make our capsule object that we can see here in the scene move forwards in the direction in which it's looking. Now its forward vector is completely different from the world forward vector, which is pointing down here, and we want to use vector mathematics here to make it move forwards. To do that, I'm going to need to create a completely new script file. Before I create that file, I want to adjust one of the settings inside of Unity. From Unity 5.3 onwards, sometimes on Windows, Unity will open up the Microsoft Visual Studio Editor every time you try to open a new script file. That's because Unity specifies Microsoft Visual Studio as the default code editor, and I want to change that because in this course I want to use the MonoDevelop editor because that's the editor you can use on many different platforms, including Windows and Mac. Now, to specify MonoDevelop as the default code editor, you may need to change a setting inside the preferences. So you may need to choose Edit here from the File menu, then select Preferences, and from the Preferences dialog under the External Tools setting, choose External Tools, and for the External Script Editor, make sure that MonoDevelop is specified here in the drop-down list. By default, it may say Microsoft Visual Studio. We don't want that, so ensure that MonoDevelop is selected here. And when I exit the Preferences dialog and I move down to the Project panel down here, I'm going to create a completely new script file. To do that, I'm going to right-click and choose Create, and then from the context menu, choose C# Script. So I'm going to select that from the menu here, and I will name the script file Mover. Notice this very general but descriptive name. It's general because we can apply the Mover script to many different objects to make them move, but it's also descriptive because it tells us what the script file will do when it's attached to an object. So I'm going to drag and drop the Mover script onto the capsule object by selecting its name here in the hierarchy panel. And when I select the capsule, you can see in the object inspector that the Mover script component has been attached. I can open this inside MonoDevelop by double-clicking the Mover script from the project panel down here, and this will open the script file inside MonoDevelop, which you can see here. This is the MonoDevelop editor. Now, sometimes when you create a script file, it may display this warning about line endings. For the Windows platform, I want to make sure that we convert these, so I'm going to choose OK here. Now, sometimes it will do that every time you open up a new script file. You probably don't want that. So I'm going to change this inside the options by choosing Tools and then choose Options. And from the Options menu here under Text Editor General, if I select that, you can see under Coding, it says Line Ending Conversions. And what should it do? Should it always ask us whether we should convert, or whether should it always convert them? I'm going to select Always Convert Line Endings and then choose OK. Now, the code editor, you'll notice that I have applied some syntax highlighting. If you're using the MonoDevelop default settings, your code editor may not look like this. You can easily customize it to match this color scheme here by choosing Tools, Options, and moving down under Text Editor to Syntax Highlighting. So I'm going to choose Syntax Highlighting. Now, by default, your color scheme may look like this under the default color scheme, but this white background hurts my eyes, so I don't want that. So I'm going to make sure that Oblivion is selected here for the syntax highlighting and then choose OK. And that really configures MonoDevelop for use. Now, of course, what we want to do is to code this Mover class so that our object moves forwards in the direction in which it's looking. So I'm going to get started by creating two variables. One variable is going to encode the speed at which the object moves. So let's just bring that into here by choosing public. And I'm going to make that a floating point variable. So it's going to be max speed here. And remember, by making them public, you will have the variable appear inside the object inspector in the Unity editor. So this is going to be max speed, and this is measured as a speed in terms of meters per second. So the next variable I want to create is a reference, an internal reference. So it's going to be a private variable, a reference to the transform component attached to the capsule object. That's so that I can access the position variable and adjust the speed of the object. So I'm going to choose private and transform, and I'm going to select this transform, and initially it's going to equal null. Now we have this start function here, which happens when the level begins, and I could use this to assign the transform variable to the transform component. However, I'm going to use the awake function instead. So the awake event is called automatically by Unity. But awake is called always before the start function. So if you create or initialize all of your variables inside awake, you can guarantee that by the time the start event happens, all of your variables and all of your references are already initialized and you're working only with valid data. So generally you want to initialize your variables inside awake. So I'm going to choose this transform, and it's going to equal get component, and it's going to equal the transform component. Remember, the get component function allows us to specify a component to retrieve. In this case, we want to retrieve the transform component, and the entire expression here is evaluated and the result is assigned to the variable this transform. Now, having retrieved the transform component, we're left with the update function or the update event. And you may recall that this event happens once per frame. This means that if our game is 70 frames per second, the update function will happen 70 times per second. This makes the update function a really great place to code variables and functionality that change an object continuously over time. So here is the place where we want to update the speed of our object. Now to do this, we're going to choose this transform, and if I press the period symbol or the full stop, we get a range of the properties and the methods that we can use, and I want to update the position of the object because I want to accumulate the position. That is, on each frame, I want to take the current position of the object and then displace it, moving it further one way or another. I want to use plus equals to say equals itself plus whatever we're going to put on the right hand side of this expression. Now, of course, I want to move the object in the direction in which it's looking. The way I can do that is take the transform component, and if I press the period symbol and I type, for example, up, you can see that we get access to the up vector, and this is the local up vector of the object, and this is defined as a vector3 object. So that means that it's defined from an X, Y, and a Z axis. Additionally, we can also access the right vector if we want. And again, this is defined as a vector3 object. But of course, since we want to move in the direction in which we're looking, we want to access the forward vector. So this is always going to represent the direction which is forwards for the object itself. Not the forwards vector for the world, but the forwards vector for the object. Now on its own, the forward vector doesn't represent any kind of displacement or distance. It simply expresses a direction. So if we ask the question, which way are you looking? The forward vector can answer that, but it can't tell us how much we should move in our direction. For that, we need the max speed variable, combining it with the vector using arithmetic. So what we can do is take a direction, in this case, the forward vector, and when you multiply that by a single number, in this case, speed, what you are effectively doing is scaling the vector and telling Unity how much we should move in that direction. Of course, if I wanted to move backwards, I would simply use a negative speed to move the other way, to inverse the direction. But I don't want to do that here. I want to move forwards. So I'm going to end that statement here. Now this statement is not entirely completed. There's an important ingredient missing that we're going to see later, but I'm going to leave this statement as it is for now and press Ctrl S on the keyboard to save that code. Now what I'm going to do is I'm going to go back over to Unity here. So again, when I go back to the Unity editor, the bottom right hand side, we get the whirly icon to indicate that the code is compiling. We don't get any errors in the console. It's completely clear. So the code is valid. If I select the capsule object, you can see we have our movement script attached and the max speed is set to 1. I'm just going to, for now, reduce that to 0.1. And when I press play on the toolbar, the object will move along its forward vector. So that's the blue arrow here. So if I press play on the toolbar, the object begins to straight away, or when Unity thinks about it, there we are, it's starting to move in the direction it's looking. This also means that if I rotate the object to look in a completely different direction, in fact, let's rotate it this way, let's rotate it way all the way up there. So we're now looking into the sky and I press play, again, the object moves in the direction in which it's looking. And that's how simple it is. We can simply take a direction, multiply it by a number, that is its speed, and Unity does the rest for us. That's really simple vector mathematics. But I mentioned that there was an ingredient missing, and we'll see what that is next.